right, day 21. Gonna be part two of our snake game, and we can go ahead and just get on with it.
Hey guys, welcome to day 21 of 100 Days of Code. Today we're going to learn about class inheritance, slicing, and we're going to be finishing up our snake game. Today I wanted to introduce you to another really important concept in object-oriented programming, which is the idea that classes can inherit from other classes, inheriting attributes, inheriting methods, basically a way to make it simpler to modify classes and give them more capabilities. Now we're also going to be looking at how Python allows us to slice things like lists and dictionaries, and we're going to be looking at how we can do that. And once we've acquired all of these skills, then we'll be able to finish up our snake game and complete the last 4 stages. So detecting collision with food, creating a scoreboard, detecting collision with the wall and with the tail. Once you're ready, head over to the next lesson and let's get started learning about class inheritance. Let's talk about another feature of object-oriented programming that's really handy, and it's something that we call class inheritance. How does this work? Well, let's say that you code up a robot chef and you give it a bunch of functionality, like you tell it how to bake, how to stir, how to measure, and then at some point you decide, actually, in my restaurant I also need a pastry chef. Now, this pastry chef will need to know some of the things that a chef knows how to do, but it also needs something extra. So you don't want to create this pastry chef entirely from scratch. Instead, what you want to do is you want to be able to take the methods you already defined for the chef class and then just add to it. Add a few other relevant methods, like how to knead dough or how to whisk some eggs. So this process of inheriting behavior and appearance from an existing class is known as class inheritance. When we're talking about class inheritance, you can inherit both appearance, so attributes, like for example, if you inherited the same eyes as your mother, or if you inherited the same nose as your grandfather. But you can also inherit behavior. So maybe you chop tomatoes in the same way that your dad chops tomatoes. And if you believe my mother, I'm lazy in the same way that my dad is lazy. So not only can we inherit appearance, but we can also inherit behavior. Now, how does inheritance actually work in terms of the code? Well, we can define a class, let's call it fish, and it has an initializer. Now, in order to get this fish class to inherit from another class, all we have to do is to add a set of parentheses after the name of the class and then provide the class that we want to inherit from. So in this case, our fish is inheriting from the animal class. And then in order to get hold of everything that an animal has and is, so its attributes and methods, all we have to do is
Okay.
inside the init add this super.init. And this super refers to the superclass. So basically initialize everything that the superclass can do in our fish class. Let's take a look at this in terms of real code. First, I'm going to create a animal class, and this animal class is going to have an initializer where we're able to define some attributes, right? So let's say that all animals have 2 eyes. So num eyes equals 2. Now, at the same time, I'm also going to define a method associated with this animal class. Let's say that all animals know how to breathe. So inside this breathe method, I'm going to keep it quite simple. I'm just going to say inhale, exhale. So that's breathing, done. Now, later on, I decide to define a fish class. And this fish class probably also knows how to do certain things. So, for example, maybe it knows how to swim, right? Right now, if I create a object from this fish class, let's say I create an object called Nemo that's created from the fish class, then I can say Nemo.swim. And you can see when I run this code, it says that Nemo is moving in water. Now, what if I wanted this fish class to inherit everything that the animal class can do, including the attribute number of eyes and also the method breathe? All I have to do is to add this animal class after the name of the fish class inside parentheses, and then I have to add the initializer, and inside the initializer I have to trigger a call to the superclass, which is in this case the animal class, and then I'm going to call the initializer like this. So now what these two parts of the code does is it allows anything that's created from my fish class to inherit all of the attributes and methods from the superclass, which is the animal class. Now I can get my Nemo to start breathing. And you can see if I hit run, then it will also inhale and exhale. And in addition, if I wanted to print nemo.num eyes, then you can see this is also going to print too. So now my object that's created from the fish class now has access to all the attributes and methods from the superclass that inherited from the animal class. Now, what if I wanted to inherit a method? So get all the things that it does, for example, the breathe method. But what if I wanted to modify it a little bit? So for example, a fish does in fact breathe, but it kind of breathes underwater. So let's say I want to define the breathe function, and I want it to have the same functionality as the superclass which I'm inheriting from. So I want to print inhale, exhale, but I also want to do something extra. Well, in this case, we would get hold of the superclass and then call breathe on it. This means we're going to do everything that the breathe method from the superclass does, so all of this, but afterwards we're going to do something a little bit more special. So we're going to say we're doing this underwater. Now, when this line nemo.breathe gets run, you can see what happens is it will print out inhale, exhale, and this comes from the superclass's breathe method here. And then afterwards, it will print its own unique twist on breathing, which is doing this underwater. By learning about inheritance, what it allows us to do is to take an existing class that we've created or somebody else has created and then build on top of it without having to reinvent the wheel and redefine everything that's in that class. So in the next lesson, I'm going to show you how we can inherit from the turtle class to upgrade the turtle to be able to do extra things, such as creating a piece of food or creating a scoreboard. For all of that and more, I'll see you on the next lesson.
Dang it. I meant to go back real quick.
Let's
So what she's showing right here, mainly what I'm gathering is with the class that's inheriting from another class, you're just basically calling the same exact function or defining the same function, but you're just putting inside of it super dot function name, and that's pretty much it. Then afterwards, then you can modify it to specifically cater towards the new inherited class. Yeah. Alright, given the following class dog, define initialization self.temperament equals loyal, and define bark, print woof woof. How do you create a class called Labrador that inherits from the dog? Yeah, class Labrador, define initialization. This is not it. Um, these two. Oh, okay. You want Labrador. Right? You want Labrador. It's supposed to have dog within here, right? 'Cause this isn't correct. Technically, it's supposed to be Labrador with dog in there. I guess if you just don't want it to initialize the same way, I'm going with this one. Okay. Is recommended but not strictly required. Yeah, that makes sense. Uh, what will this code print? Doggo equals dog. Okay. Uh, a dog is doggo.temperament, which means loyal, whereas Sparky is a Labrador. Sparky is, so a dog is loyal. Both of these have that. And Sparky is a Labrador. Sparky is gentle. What will this print? Sparky equals Labrador. Okay, so we have a Labrador. We need bark. So super.bark will take woof woof and then print greetings good sir, how do you do? Cool.
Alright, so now that we've learned all about inheritance, it's time to apply the theory to our snake game. And we're going to use it to detect collision with food. Our snake should be able to hit a piece of food, which is just going to be a blue circle, and every time it touches the food, the circle moves to a new random location on the screen. If we take a look at our code, you can see that the main.py controls the entire game. It dictates how the screen should behave and how the snake behaves. Now, everything that's to do with the snake, its appearance and behavior, is all captured inside a class. So everything snake related is inside the snake class. So what we want to be able to do is to create a new food.py file, and this food.py is going to be its own class. And the food class is going to know how to render itself as a small circle on the screen, and then every time the snake touches the food, then that food is going to move to a new random location. So let's create the initializer for this food class. And one of the things that we're going to need to do is we're going to need to import turtle. So from the turtle module, let's import the turtle class. And this piece of food that we're going to see on screen is going to be a turtle object. Instead of creating it as an attribute in this class, so self.food equals turtle like this, what we want to be able to do is we actually want this class food to inherit from the turtle class. So that way, this food class is going to have all of the capabilities of the turtle class, but it's also going to have some specific things that we're going to tell it how to do so that it behaves like an actual piece of food. Here's a quick challenge. From what you learned in the last lesson, can you figure out how to make this food class inherit from the turtle class? Pause the video and give that a go.
I think I got it right there.
Alright, so we mentioned that there's only two steps we need to do. First is after the name of the class, we add some parentheses and then put in the name of the class that we want to inherit from. So in this case, it's the turtle class.
And to be precise, it is the class, not the module.
And then the next thing we need to do is we need to call the turtles init method inside the foods init method. And you can see that as soon as you've
So
added this
let's do data
inheritance
first.
here, this init starts giving us a warning. And when you click on it, you can see it says call to init of superclass is missed. So it actually knows what we need to do next. That means if we click on the light bulb, we can actually automatically just add in the superclass's call. This, of course, you could just type it out and it's good for practice. But in case you're ever wondering if you get these warnings, you can always take a look at what PyCharm is recommending. Now we've actually created our food class and we've inherited from the turtle class. What that means is we can now start using things that are from the turtle class. For example, I can straight up say self.shape and it knows what shape is. This is a method that the turtle class has that I'm now going to modify in my food class. So when I initialize a new piece of food, I'm going to make sure that it has a circular shape. And I'm also going to get it to pen up so that it doesn't draw. And then I'm going to define its size. And there's something called shape size, which I can use. And what this allows me to do is to stretch the turtle along its length and along its width. Now, I'm not actually going to stretch it bigger than it is. It's normally 20 by 20 pixels, but I want to turn it into 10 by 10 pixels. So I'm going to stretch the length by 0.5. So I'm basically going to halve it. And then I'm going to stretch the width also by 0.5. So now it should be a 10 by 10 circle, which I've created by defining the shape size. Now remember, all of these methods, shape size, pen up, shape, comes from this turtle superclass, and we're only able to use it because we're inheriting from the superclass. So that our food class is now also sort of a turtle, but it's more like a souped up turtle. Finally, let's go ahead and define the color, which I'm going to set as blue, but of course feel free to set it as anything you like. And I'm also going to set the speed of my turtle to fastest. This way I don't have to look at the animation of the food being created at the center of the screen and then moving to the location that I want it to. Speaking of moving, we're going to need to use the goto to get it to go to a random XY location. So let's import the random module and let's create a random X, which is going to be random.randint. Remember that our screen is 600 by 600, so that means that our x-axis goes from minus 300 to positive 300, and our y-axis goes from positive 300 to negative 300. Now we don't want our food to be right at the edge of the screen because it'll be really hard to get the snake to go to right at the edge. It'll probably just die on the wall. So we want to maybe subtract this a little bit. So we can go from minus 280 to plus 280 and the same on the y-axis. So let's generate a random integer from minus 280 to positive 280. And let's generate a random y integer in the same range. So now we can tell our food to go to a random x and a random y. All of this is going to happen as soon as we create a new food object from the food class. Remember, whenever you initialize a new object from the class, the init gets called. Back in our main.py, right below where we initialized our snake, we're going to initialize our food. So food equals the food class and then parentheses. And of course, we need to get hold of our food class from the food file, like this. Another thing you'll notice is that this turtle is now grayed out because we're not using that class anywhere inside the main.py. So we can delete that, which gets rid of all our warnings on this page, and we get the green check mark.
Alright, there's been a lot going on. I need to make sure that I have everything in here. Import food. She said that we are...
Delete that, we're not. Another thing you'll notice is that this turtle is now grayed out because we're not using that class anywhere inside the main.py. So we can delete that, which gets rid of all our warnings on this page, and we get the green check mark. Our food.py looks good, our snake.py looks good, And we're now ready to go ahead and run this code. Notice how we've got our snake moving around on screen, and at this point it doesn't really matter about the walls. It's
Yeah, when did she put food in there?
good. Our snake.py looks good, and we're now ready to go ahead and so we can delete that, which gets turtle is now grayed out of our food class, new food object from the food class. Remember, whenever you initialize a new object from the class, the init gets called. Back in our main.py, right below where we initialized our snake, we're going to initialize our food.
Okay.
So food equals the food class and then parentheses. And of course, we need to get hold of our food class from the food file, like this. Another thing you'll notice is that this turtle is now grayed out because we're not using that class anywhere inside the main.py. So we can delete that, which gets rid of all our warnings on this page, and we get the green check mark.
Why am I getting an error? My food equals food. Oh, food, food. Okay, that should do it. Cool. Now we just need the collision.
Our food.py looks good. Our snake.py matter about the walls. It's just moving around anywhere it likes. But more importantly, we've got our food being randomly generated on the screen right here. Now the next step is how can we detect when the snake and the food have come into contact, and then to tell the food to move itself to a new random location? Well, we're going to do that inside our main.py. Right after we've got our screen updating, our snake moving, then we're going to detect collision with food. And we're going to do that by using a method from the turtle class called distance. The distance method works by comparing the distance from this turtle to whatever it is that you put inside the parentheses. So the x could be a pair of numbers, x and y, or it could simply just be a turtle instance. So you're comparing this turtle against another turtle, and you're trying to get hold of the distance between the two turtles. So what that means is we can check to see if the distance from the first segment of the snake, so remember that would be snake.head.distance, and then the distance that we want to know is what is the distance from the snake's head to the food. At this point, you can check to see if it is less than a certain amount, then it's pretty likely that the snake head is now colliding with the food. So we know that the food is 10 by 10. So if we add a bit of a buffer, let's just say if the snake head is within 15 pixels of the food or even closer, so if the distance is less than 15, then we can be pretty much certain that they've collided. So let's go ahead and print something. I'll just write nom nom nom. So if we go ahead and run our code, and let's just get our snake back into view, and if I now go and touch this piece of food, if I can,
Getting an error here. If
I'm much certain that they've collided. So let's go ahead and print something.
I've got the same thing here. everything looks the same.
I'll just write nom nom nom. So if we go ahead and run our code, and let's just get our snake back into view, and if I now go and touch this piece of food, if I can, then you can see nom 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 being printed in the console. Now let's go ahead and touch it again. You can see as soon as I collide with that food, I get that print statement executing. So now, instead of just writing nom nom nom, let's figure out what we need to do next. What we want to happen is the food
Yeah, I don't understand why this is not. It was my food the whole time. All right, I'm gonna get it. There we go. And it. Okay, cool. Need to remember my variable names.
food should go to a new random location. And of course, that comes from this part of the code. So why don't we go ahead and create a new method, which we'll call refresh. And this refresh method is going to create a new random x, a new random y, and then get the food to go to that new random location. Then inside our init, we can simply just call self.refresh. So be careful that you didn't write reset, because that's one of the methods from the turtle class that we're inheriting from. But what we actually want is to call this refresh method so that the food goes to a new random location. And then back inside our main.py, when the snake head collides with the food, then we're going to get the food to refresh its own location. So check this out. Now, when I hit the food, then you can see the food now appears at a new random location, like that. Now, depending on how accurate you want the snake to hit the food, so it might need to hit it dead on, or if you're happy with it just gliding past and counting that as a collision, then you could decrease the number here from 15 to 10. Now, I've done a bit of testing, and this number seems to be the best distance in order to get a valid collision, but feel free to tweak around with the number and see how it goes. There we go. We've managed to figure out how to create a piece of food by inheriting from the turtle class, get the food to be generated, and then to move to a new random location every time the snake head collides with the food. Now, I know that in the snake game, the snake segments increase once it hits a piece of food, but we're only going to add that functionality at the very end of this project when we're detecting collision with the snake tail. So don't worry about that for now.
I don't know why it wasn't working with
Guys,
10,
we've
but
already come really, really far.
it's doing
We've
it now.
done all of this, and now we're on this stage, creating a scoreboard. So what we want is to be able to write some text in our program that keeps track of the score, of how many pieces of food we've actually managed to eat. Now the score should update every single time we hit a new piece of food, and it's going to stay there and keep updating itself every time we hit a new piece of food. Now, this scoreboard is also going to be a turtle. So one of the things that you can do with your turtle is you can get it to write a piece of text. And this is what the method looks like in the documentation. You can tell it what it should write, what kind of alignment you want. Do you want it to be in the center of the screen, on the left or right side of the screen? And then what kind of font you want. So the font name, font size, and font type. So normal or heavy or bold or underlined. And we would call it more or less like this. So here's a challenge for you. I want you to go ahead and create a new file called scoreboard.py. And inside this file, I want you to create a new scoreboard class. Now, this scoreboard class is going to inherit from the turtle class, just as we did with the food class. And then the scoreboard is going to be a turtle which knows how to keep track of the score and how to display it in our program. Feel free to choose whatever font you want, whatever size you want, but the end outcome we're looking for is something that looks a bit like this, and the score is going to need to be tracked inside that scoreboard class, and it needs to be increased by 1 every single time the snake eats a piece of food. You're going to need the help of the documentation. You're going to need to read up on how this turtle.write method works. And you're also probably going to need this turtle.clear so that you clear the writing every time you update the score. Have a think about how you would solve this, and then go ahead, pause the video, and give it a go.
Okay, so oh yeah, because we're doing a class, not a definition. Okay. Okay, let's find our. At this point, I should just have the dang thing bookmarked. Now, admittedly, I wasn't really paying attention to the last part she was saying about some of these in here that I would be needing. I think I saw clear, but maybe this has something to do with it. Um, Score equals 0. Um, Define, add, point, score plus equals 1, self.score. dot score. Cool. Um, Now I think we'll go in here. We'll do a my scoreboard equals. Make sure to import that just to keep things in alphabetical order. Import scoreboard and import time. We'll put scoreboard dot scoreboard. And then I think I want it to write score equals my scoreboard dot score. And we'll do a line equals center just to see what this looks like. Let's do a move equals false. Oh, still not seeing it. Although it could also be because of the black background. But we want to do I'm thinking, I believe we will want to go to call it 280 0. And we'll even do sort of, is there a font color, pen color? Maybe a fill color. Go with white. Probably not going to work, but well, it's in the right spot. But not entirely sure how to get it to change its shape from that to text. think that's what we're looking for. Yeah, let's just see what she does for the text part. I think we've
All
got
right, so
everything
the
except
first
for
thing I'm
just
going to
one
do
single
is I'm
line.
going to create my scoreboard class. And as I mentioned, this class needs to inherit from the turtle class. So from the turtle module, let's get hold of the actual turtle class so we can use it inside this file. And then I'm going to add it to my scoreboard as the superclass. Now if I create my init, I can go ahead and use this little light bulb to insert the superclass call. So now my scoreboard is a class that can do everything a turtle class can do. And one of the things I want it to do is I want it to keep track of the score. So let's say it starts out at 0, and we want to be able to write this onto the screen. So we can say self.write, and
That is right there, huh? Well, that's what I'm using. Alright, let me see what she
let's use
does.
an F string to say score, and then we can insert the self.score value in here. And then we can add whether if we want it to be aligned to the center, for example, and then we can also add a font if we need to. Let's use the same font as here, Arial, and then we're going to make the font size a bit bigger, and then we're going to keep it as normal. So I'm going to choose an Arial font, size 24, and then the style is going to be normal. And as you can see here, I'm getting a warning here, and it's telling me that it expected a tuple, but instead it just got a single string. So let's just compare this against the documentation code, and you can see that this is meant to be a tuple instead of just a single piece of string. So let me go ahead and fix that. Let's add some parentheses around this, and then this Arial is going to be a string, this 24 is going to be a number, and the normal is going to be a string. And now our errors have gone away. So now going back to our main.py, let's go ahead and create our scoreboard
Wait, what was that?
as an object from the scoreboard class, which of course means that we need to import it into this file. So from the scoreboard file, import the scoreboard class. And now if I run this code, somewhere in the middle there, I've got a scoreboard. But because it's actually black, you can't really see it. It's really important that we change the color of the scoreboard turtle before we write the text. Because if it was written as black and then we change it to white, you still won't notice a difference. So if I change the self.color right here to white and I hit run, then you can see that scoreboard showing up. But if I move this line of code to after we've written it, then it won't actually make a difference. It's still written in black somewhere on there. Now, in addition, we want to get rid of the turtle that shows up when we create our scoreboard, because all we want it to do is we want it to write. We don't want it to actually show up a turtle. Self.hide turtle, and now that little arrow disappears. And we probably don't want this scoreboard to be bang in the middle. So let's move it. Let's tell it to go to a particular X and Y position. Now in the example here, I've got it in the center right at the top. So we can keep the X as 0, but let's move the Y further up to the top. So let's say something around 270. And now if we test it again, you can see that the turtle went to the top, but this happened after this line was already written. So again, this needs to happen before we write. And now if we refresh, you can see it's moved to the top, but it's also drawn a path to there. So instead of doing that, we can tell it to self.
Alright, so mine is not drawing the path. I got that, but why is it not moving from where I'm at? got 0. She's got 270. I've got 280, but wait, I've got the pen up. Right. Score. I've got equals, but same difference. Okay. I think that's it right there.
Dot pen up before it moves to this location.
No.
There we have it. We've got our score.
Is it because her go-to is... apparently. Um, yeah, it's just really particular about the order of things, I guess. Um, so, only thing is, yeah, we'll do. Not sure why mine is still... Well, yeah, okay, fine. Sure, that'll work.
Showing up at the top. Now, all that's left to do is to keep track of the score and to increase it whenever the snake hits a new piece of food. So we know that that happens inside this if statement. When the snake head collides with the food, then we refresh the food, but we also want to increase the score. So let's go ahead and create a function inside our scoreboard class called increase score. And this function is going to take the self.score and add 1 to it. And then it's going to call self.write.
Way ahead of you.
So now, back inside our main.py, we can get hold of our scoreboard object and tell it to increase score whenever the snake collides with the food. So let's test this again. And if I manage to hit the food, then you can see that the score is being updated. But what's happening is that the score is being written on top of the previous scores. So it's just all overlapping with each other. So instead, what we need to do is between each time we update the scoreboard, we actually have to delete what was previously on there. And because we've now got these two lines, which are pretty much identical in two places, let's go ahead and create a function instead. We'll call update scoreboard. And inside this function, we'll have our self.write. And we can call self.update scoreboard here and also here. So now before we increase the score and call update scoreboard, we can call self.clear to clear the previous text that was written by this turtle, which is the scoreboard. Now, if we run this again, you can see that when I do score, my scoreboard is wiped and then the new text is written. so it doesn't overlap with the previous scoreboard. The final thing I want to do, just as a finishing touch, is I don't like having these hard-coded pieces of text inside the body of my programs. So instead, it would be much better if we could take these pieces of text out and create constants with them. So we could have one that's called alignment, set to center, and then another one called font, which is going to be set to this tuple. And then I can use these constants down here. So align equals alignment, font equals font. That way, when I decide that I want to change something about the alignment or the font, so for example, instead of Arial, I might go for something that is a little bit more video gamey sort of font, like Courier, then I don't have to dig through the body of my program to find out where it was defined. I can just look at the top, which contains all the constants, and then fix it right here. That shouldn't have changed any of the functionality. It's just made our scoreboard look a bit more video gamey, and you can see it works perfectly.
It's good. It's getting there.
We've coded up the majority of this game now already. All that's left to do is to define the two situations where we might get game over, and that is detecting collision with wall and detecting collision with tail. So let's tackle the easier one first. We want the snake, once it gets past a certain point that's very close to the four walls, to trigger the game over sequence. So we know that we have a 600 by 600 screen, and the X and Y axis go to 300 and minus 300 at all four sides. So if we create a boundary box that's say 280 here, 280 here, minus 280 and minus 280, then as soon as the snake head touches that position, then once it zooms past it, then we can say that the snake has pretty much hit the wall. Now, this number is not perfect. It's just what I found to work after doing a lot of testing. And this is the case with a lot of games. You have to test it, run it, see if it works the way you want it to. But let's go ahead and add a comment, detect collision with wall, and let's create our if statement. So what we want to say is if the snake.head has a x coordinate that is greater than 280, so it's gone too far to the right, or if it has a x coordinate that is less than minus 280, so it's gone too far to the left, or if it has
Why is it not popping up? Game over equals. And we'll do need our parentheses. Oh, and stop the game.
As a y coordinate that's greater than 280, so too far to the top, or if it has a y coordinate that is less than minus 280, so it's gone too far to the bottom. If any of these four situations occur, then it basically means that the snake has hit the wall. So what do we want to happen when the snake hits the wall? Well, we want to change this game is on to false, because what that's going to allow us to do is to exit the while loop and basically end the snake movement and end the game. Let's go ahead and test this out. So let's let the snake hit the wall, and you can see it no longer continues moving forwards. But for the user, this might be a little bit confusing. It doesn't seem like it's actually game over. It seems like it's just crashed. So let's go ahead into our scoreboard, which does a lot of the writing, and let's create a new function, which is going to be called game over. And this game over function is going to simply just write some text, not the score, but instead it's just going to write game over onto the screen using the same alignment and the same font. But instead of writing it at the position which we initially defined, which is right at the top, let's go ahead and get it to go to the center, which is at 0, 0. So now when the snake hits the wall, not only does the snake stop moving, but we're also going to get the scoreboard to trigger the game over.
Gotta catch up to her. Alright, we can take this. Instead of score, we'll just write game over. Two, zero, zero. Nice.
Over sequence. So that means when it hits the wall, game over shows up in the middle of the screen, and you can still see the score that was written previously because we don't actually hit clear before we write this game over.
Mm-hmm.
And this means that the user can see that the game is over, the snake has stopped moving, and they can see their final score. So let's try to score some points. And once I've done that, I'm going to hit a wall and it's game over, and I can see that my score was 2. All right, guys, we're at the final stretch. All we have left to do now is to figure out how we can detect when the snake collides with its own tail. As a snake gets longer and longer, it's more likely that at some point the head might hit some part of the tail. And in the snake game, this means it's game over. So we have to figure out how we can detect this and then trigger the game over sequence. One of the things that we've left until now is a way of extending the snake every time it gets some food. Because at the moment, what's happening is our snake is staying the same size with only 3 segments. But now we need to change that. We need to add a segment to the snake every single time it hits the food so that it grows in length and we can start detecting collision with the tail. The place we're going to do that is inside our snake class. So we're going to create a function that's going to be called extend. And this extend function is going to add a new segment to the snake. So we're probably going to need another function, which is going to be called add segment. And this is going to require the position to add the segment to, essentially. Notice how this is the part of the code where we actually add the segment. So let's take it out of the for loop and put it into the add segment. And so we can now call this function self.
Okay. Where are we? I think it was right back here, huh? Yeah. Okay. Add segment. Actually, I guess we will. I was thinking I got away from this. Um, Wait, where's her teleport? Where's just go to position? That's right, okay. So she has starting positions instead of her range equals, I want to say it was a list. And we have 0, minus 20, minus 40. So she does position, and we can take this out entirely. And self dot add segment.
Segment. So let's take it out of the for loop and put it into the add segment. And so we can now call this function self.addSegment and then pass in this position that we're.
Okay, I see. And that's where this comes in. Slytherin dot segment. Yeah, I'm not sure where to put or what to do for the position now.
Looping through. These two functions together are going to create our snake. But in addition, we're going to use this add segment when we want to extend the snake. But what position do we want that last piece to go
That's
to?
it.
Well, we're going to get hold of the list of segments and we're going to get hold of the last one. Remember that with lists in Python, you can write a negative number so that you start counting from the end of the list. For example, if our list was 1, 2, and 3, then this list at -1 position would be 3. Effectively, we're getting hold of the last segment in our list. And then we're going to get hold of its position. And remember, this is a method that comes from the turtle class, and we can call it by writing position and then parentheses, and we'll get the position of that segment. And then we're going to add this new segment to the same position as the last segment. So now, if inside our main.py, every time our snake collides with the food, then not only are we going to refresh the food, but we're also going to get the snake to extend itself. So let's go ahead and run this game again. And notice how this time, once I hit the food, the snake actually extends itself and it gets longer each
Well, that's
time.
not supposed to happen.
So now
Alright, I'm gonna just go back a little bit just to make sure.
segment in our list. And then we're going to get hold of its position. And remember, this is a method that comes from the turtle class, and we can call it by writing position and then parentheses, and we'll get the position of that segment. And then we're going to add this new segment to the same position as the last segment. So now, if inside our main.py, every time our snake collides with the food, then not only are we going to refresh the food, but we're also going to get the snake to extend itself. So let's go ahead and run this game again. And notice how this time, once I hit the food, the snake actually extends.
Well, that's not good. Line 26. Shouldn't be any issues there. And it just all falls apart. just to be sure. Try and reopen this. I see entirely no reason for this not to work. Well, we're so close to the end here, I'm just going to,
Extends itself and it gets longer each time. So now we're able to think about how to detect tail collision, because as the snake gets longer, this tail collision becomes more of a problem. We're more likely to get tangled with our own tail. Let's go ahead and add a comment here which will say detect collision with tail. And the way that we want to check this is we want to say if the head collides with any segment in the tail, then this means that we're going to trigger the game over sequence. So how can we detect if the head collides with any segment in the tail? Well, we could loop through our list of segments in the snake. So we could say for segment in snake.segments. So out of all the snake segments, let's go through each one of them. And then we can say that, well, if the snake.head has a distance of, let's say, I don't know, less than 10 from any of those segments that we're currently looping through, well, that probably is a collision, right? So in that case, we're going to set the game is on to false, and we're going to get the scoreboard to trigger the game over sequence. Now, there's just one problem with this. If we go ahead and run the code as it is, you can see that immediately we get game over. And the reason is because out of all of the snake segments, the head is the first segment. So when we loop through each of the segments, the first segment is going to be the snake head. And so we're detecting if the snake head has a distance to the snake head of less than 10, which of course it is going to. So we need some sort of way of bypassing the snake head. So we could say if the current segment that we're looping through is equal to, so double equal, to the snake.head, well then in this case we're going to pass. But if this is not the case, so in the elif after the if statement, then we can check to see if the snake head has a distance to the segment of less than 10. Now, if we rerun this code, you'll see that it works exactly as we expect it to. We can move our snake around, and as soon as the head hits the body, then it's game over for us. We've pretty much now completed the snake game. But in the next lesson, I want to talk about a special functionality in Python, which is called slicing. And this is something that you will often see in code in the wild. And we'll use that to improve our code just a little bit more. So for all of that and more, I'll see you there. Now, while our snake game works now with all of the functionality that we set out to create, there's just one thing that bothers me a little bit about this code, and it's how wordy this section is. All that we're trying to do is make sure that we're detecting the distance from all of the segments that we're looping through in snake segments other than the first one. Surely there's an easier way of doing this rather than writing all of these lines of code. And indeed there is. But in order to use it, we have to learn about a Python concept known as slicing. Let's say that we had a list of piano keys all the way from A to G, and we wanted to get hold of a small section of this list. Let's say we wanted to slice the list so that we only get the C, D, and E keys from this list. How would we do that using Python? Well, one way of doing that is you could write a for loop and you could check, well, is it C, is it D, is it E? If so, then add it to a new list. But that's really convoluted. We have a much better way of doing that in Python, and it's known as slicing. This is what the syntax would look like. We would get hold of our list, piano keys, and then we would use a set of square brackets, but instead of accessing just one item with a position, we get a set of items by slicing it from position 2 to position 5. This might be a little bit confusing because, well, we know that A is at position 0, B is at 1, C is at 2, but the one at position 5 is actually F. So how does this get us C, D, and E? Well, you have to visualize it like this. Imagine that 0 position is actually at the beginning of the list, before where A starts. And at the end of the list, we're actually at the slicing position of 7. If we think about it this way, then the way that we're slicing this list is going all the way from position 2 to position 5, then of course we would end up with C, D, and E. If you take a look at this code in my replit, I've essentially got the same code that we saw in the slides, and we're slicing this list of piano keys from position 2 to 5. When I hit run, you'll see that what gets printed is C, D, and E, exactly the slice that we wanted. Now, there's other things that you can do with slicing that's pretty cool. So, for example, if you wanted to slice from position 2, which remember is right here, because we're starting at 0, 1, and 2, and you want to slice it to all the way to the end of the list, well, you can just omit the second number. You can just have 2 and then a colon. Now, when you slice this, you get all of the rest of the list starting from the position that you specified. And this works in the opposite direction as well. Let's say that we want to get hold of everything up to position 5. Well, we could omit the first number, add a colon, and then after the colon, specify the end slice position, and now we get all of the items in the list up to that position 5. In addition to just slicing between two numbers, we can actually specify a third number after another colon. And what this number does is it sets the increment. For example, we wanted to slice from position 2 to position 5, but we want to only get every other item. So then it would give us C, it would skip over the second one, and then it would give us E. And if I hit run, this is exactly what you see. So let's say I wanted to get hold of everything in this list, but I wanted every second item. Well, then this is what my code would look like. Go from the beginning to the end and then skip every second one. And I end up with A, C, E, and G. Now, to extend this a little bit further, we can actually use this neat trick to specify a -1 as the increment. And what this does is it will actually reverse this list for us, going from right to the end to the beginning. So essentially the increments are by 1, but it's by -1, so that way we get the list starting from the end all the way back to the beginning. And this is a really neat trick that you'll see a lot of people use when it comes to manipulating lists and tuples. So speaking of tuples, this method of slicing also works for tuples. So let's say we had a piano tuple, which remember is defined by a set of parentheses with items inside separated by commas. Well, we can use the same method of slicing to work with our tuple. So we use our square brackets. Let's get hold of the items from section 2 to 5. Then when we hit run, you'll see it gives us mi, fa, so. Coming back to our code, I have a challenge for you. Can you figure out how to use what we've just learned about slicing to change this code so that we get rid of this if statement where we're passing over the snake head, so that we are in fact only checking that the snake head has a distance to every segment other than the first segment less than 10. If you managed successfully to do this, you should be able to get rid of this if statement, change this to a single if statement, and somehow figure out a way of making this code work using slicing. Pause the video and give this a go.
For each segment in snake body, if the snake head dot distance okay, I don't even know where the slice is supposed to go. I don't think it belongs here. Um, Unless you do for each segment in snake dot segments and then you put your slice there. I think that's exactly what we're doing. Yeah. Okay. So basically one and on. I think that should be it.
All right, so we know that we want to loop through every segment in snake.segments other than the first one. Well, all we need to do is simply slice this list of segments. So we can get hold of everything that starts off from position 1 to the end by writing 1:nothing. This will give us everything inside the list other than the first item, like so. And then we can use that segment to loop through it and then check every segment in the tail against the distance to the head. And now when you run the code, you can see that it works just as perfectly as before, but we've now vastly simplified our code using the power of Python slicing. Have fun playing with your snake game and be sure to let me know your highest score because I can't seem to get past 10 and you've pretty much seen in this tutorial how bad I am at this game, but I'm sure you can do much better. And on top of that, think about ways that you might want to customize your snake game. Maybe you want to change the food to have a different color or a different shape. Maybe your snake is actually going to eat turtles. I don't know. The world is your oyster now that you've learned about so many more concepts in programming, including inheritance in OOP, as well as slicing lists and tuples. So I hope you've had fun building this game, and I'll see you tomorrow. Hey, well done on completing day 21. Now, you're getting to the point of the course where, you're going to have to start bringing some more of your own motivation. Because as we go through this, this is a marathon. It's not a sprint. If it was a 5-hour course, you could sprint through it in one day, but that's not how we become Python developers. It is a marathon, and understanding that will be key. So what I need you to do is to think about all the reasons why you must do this. You have to get leveraged. You have to think about, why is it that I want to achieve this goal? Why is it that I want to become a Python developer? Why is it that I want to complete 100 days? And the reasons might be things like, I want to be able to provide a better future for my family. Or it might be because I really want to build this project and I want it so much to exist. That was it for me anyways. When I first started learning to code, it was because I just had this idea and it had to be alive, it had to be built. So it didn't matter what hardships I had to go through, what hurdles I need to jump through, how many lessons on programming I need to take. I was able to motivate myself because I knew what I wanted at the end of that path. So focus on what that is for you. Think about what is that goal and how much you want it, and think back to that every time you start on this journey to continue motivating yourself.
All right, then. Well, I know that I'm still having this issue with the crashing, but there's no point in watching just me staring at the screen trying to figure out, because I have no idea how long it's going to take for me to get this, what appears to not be an issue caused by me, but I'm sure I have something out of order, or I don't know. I'll figure it out. Um, but for now, that is it, and the game's basically finished, so just gotta get it over the finish line. And then tomorrow will be day 22. See you then.